Moving forward to next topic, we have hyperparameter optimization. So we are talking about the practical skills where you will be wondering that how you should take the learning rate. Is it to be 0.01 or 0.001? That also depend on how many layers you will be needing and exact what problem we need to solve. Okay, so first of all, what is a hyperparameter? A model parameter is like a neural network weight which is learned automatically from the data. A hyperparameter is a setting that you choose before the training, the learning rate, the regularization strength, and the number of layer. It controls that how your model learns it. Okay, hyperparameter optimization is a process of automatically finding the best combination of these setting to maximize the validation performance. So now let's talk about some of the method. First one is the grid search, the simplest method in which you have to assign a value of the grid and try each and every combination. Three values for lambda, three for the c, so that a model has 9 values. Easy to understand, but it scale exponentially. Four hyperparameters with 5 value each. That's 625 runs. This is the curse of dimensionality, and that's why this grid search makes a impractical fact. Moving forward, we have the random search. Random search is a smarter. Instead of a fixed grid, you randomly sample each hyperparameter from a distribution for a fixed number of trials. Here the key insight: if out of 10 only 2 hyperparameters actually matter, then the grid search wastes most of its runs repeatedly useless values for the irrelevant one. Random search hits a unique value on every important dimension every trial. Same number of run, way better coverage. It almost always beat grid search and it's trivial to implement. Coming up next, we have the Bayesian optimization. That's a very good stuff. The Bayesian optimization, instead of sampling blindly, it built a surrogate model, a Gaussian process that approximate your validation accuracy as a function of your hyperparameter. Then it used the model to intelligently decide where to look on. Then the loop evaluate a few random points, fits the Gaussian process, and use a function to pick up the next best point and evaluate it, update, and then repeat the same process. This acquisition function balances the exploitation process. The most important is the expected improvement. It picks the point most likely to beat your current best. That's also called as UCB, where a kappa parameter which control that how much exploratory you want to be there. Next, we have the BO, which find a great hyperparameter in 10 to 50 trials, where random search need hundreds of it. For large budget, swap the Gaussian process for TPE, tree structure pencil estimator, the default used in Optuna and Hyperoptune. Moving forward, we have the Hyperband. For deep learning, trials are expensive. There we use Hyperband. The core idea is the successive halving, starting with many configuration. Train each for just one epoch, cut the worst half, double the budget, and then repeat. You keep only the survivors, and the bad run get killed earlier before they waste the computational power. Hyperband runs this at a multiple band level in parallel, so you don't need to guess the starting budget. The ASHA, the asynchronized version, is the default in Raytune. For any serious deep learning HPO, this is on the way. There is a golden point that you need to remember, that never use your testing set to select the hyperparameter. Always use k-fold cross validation on the training set. Once you have found your best configuration, retrain it on the full training set and then evaluate on the test set exactly once to report your final number. Using it earlier can cause overfitting to it. Some of the practical tips before we close are that use a log scale for learning rate and regularization. This spam order of magnitude and a uniform prior misses most of the useful range. Second is the warm start Bayesian optimization with 10 to 20 random trial first, then surrogate if needed. Thirdly, fix your random seed and report the mean plus minus standard deviation over at least 3 seeds. Different seeds can give widely different CV score. For small dataset under 1000 samples, use nested cross validation to get an unbiased estimation of generalization, and then treat every early stop as a free hyperparameter. The most recommendation workflow is that define your 3 to 5 most important hyperparameter, run 20 random trials, refine with the Bayesian optimization for 50 to 100 trials, pick the best CV score, retrain on the full data, and report on the test data once. So, coming towards the quick reference summary, what we have covered with the grid search, the random search, the Gaussian process, the expected improvement, UCB, about the successive half, hyperband, the k-fold CV, and the learning rate range. Thank you.